Right, it's Mr. Palmer here. Second video of the two on programming techniques. Before you continue with this video, make sure you've gone over your notes that you made on programming techniques and you understand what functions and procedures are, subroutines. You need to know what parameters are as well, okay, and arguments. So this one is about using a stack to handle procedure calls, okay. So basically you should be able to explain how does the computer remember where to go back to after completing the execution of a subroutine. Alright, so if you imagine this program running, okay, I've got it color coded in bits, but you can see, so the main program is running, that calls sub1 calls sub2 calls sub3. So once sub3 is finished executing, remember a subroutine is passing control back to where it came from, so that's going to go back in the other direction, 3 to 2, 2 to 1, 1 back to the main program. Okay, so what's the problem you got going on over here? The computer in essence needs to remember where it came from. Yeah, so what address does it need to return to? The call stack basically is a stack, as the name gives it away, data structure, which is being used to keep track of the addresses to which control is returned to when the subroutine finishes executing. If you think about a draw hexagon routine, okay, that's a mistake. It's gonna have to call the draw line subroutine 6 times, not 4 times as I've got over there. And so each time the draw line routine is called, it needs to return back to the draw hexagon program. It needs to know where it is in there, so it can then continue executing the next instruction that needs to be executed. Okay, so if you let's go back to that program where I had main calling sub1 to 2 to 3 and then back again. Okay, if that program is running, when it kicks off, sub1, the call goes to sub1. So in my stack, I'm going to push the return address to the main subroutine. Okay, so that's where my stack pointer is pointing. But then sub1 happens to call sub2. So before it moves on, it needs to push the return address to sub1 into the stack. Then when sub3 is called, it will push the return address to sub2 onto the stack. And then when we're going backwards again, when sub3 finishes executing, it needs to return control to sub2. So the stack pointer, so it is popped, the return address is popped, okay, and then each time obviously you're popping the return address to where you came from, and so as you know, every time you pop something, the stack pointer gets shifted down. Alright, notice the stack pointer is shifting and the data items are not being removed. Alright, cast your mind back and think about the reason why we need to initialize a variable after we declare it. Okay, in this case the stack pointer is shifting. The assumption is that if you push another item onto the stack, then the stack pointer will move up and the data item that was there will be overwritten by the new data item. So as far as we're concerned about when we're manipulating a stack, we don't care about if there's anything on top of the current data item pointed to by the stack pointer, because if we do need to push another item, we're going to overwrite it. Okay, so remember the memory is basically, once we finish using the memory is deallocated. Alright, and so stuff may still be there, data may still be residing there, which is why we need to initialize variables. Okay, now this whole idea of pushing and popping return addresses is quite simple. Okay, at this level, it's not that simple in daily life. In reality, the call stack can hold a large number of other things. It depends on the machine architecture, the programming language, and all sorts of other stuff. Okay, it can hold, for example, the return values that need to be passed back up, so it's got the addresses in memory of where the data is. It can be hold local variables, so when a subroutine is passing control, the local variables for that subroutine are stored in the stack, so when control is passed back, it can pop those variables back when it continues executing. Okay, you can also use it for parameter passing. Alright, that was a really short and sweet simple video basically on how the computer remembers to go back after it completes the execution of subroutine, so when it's returning control. Alright, thank you. Where's